Lesson 2 of our function unit deals with representing linear functions. Linear functions. As we talked about before, equations like y equals 3x plus 7 are linear equations. A linear equation is an equation whose graph is a line. The solution of a linear equation consists of two numbers, one for each variable, that make the equation true. So a solution, let's kind of say that again, a solution is really an ordered pair that makes the equation true. For example, if I said to you y equals 2x plus 1, can you come up with an ordered pair that would make this solution or this equation true? Well, the way I can do this real easily is I can make a function table or a linear xy table, and I could start coming up with pairs of numbers. Well, in this case, for this equation, the way it's written is really easy. Because if I just pick an x, let's say 0, then hold on one second, go back here for a second. I'm going to put the 0 right here. But if I put the 0 in, then I know that y is equal to 2 times 0 plus 1, which is just 1. So my ordered pair would be 0, 1. If I let x be negative 1, then I could say y equals 2 times negative 1 plus 1. So it would be negative 1, negative 1. The other x's that I'm going to try are 1 and 2. Why don't you stop the video and try to figure out what the ordered pairs would be, what the solution would be for x equals 1 and x equals 2. If you did it correctly, you would have found out, and you would have done this, and would have found out that 1 pairs with 3, and then with 2, you would get 2 and 5. So these are 4 possible solutions. The problem with linear equations is that there's an infinite number of solutions. Every ordered pair, every dot on that line, and there's an infinite amount of them, because we just dealt with 4 integers. But what if I used 1/2? Or 0.5, well, that is 1/2, or 0.7, or 0.0012, or 0.13578, or 2.6789. You're getting the idea. There's an infinite amount of answers that I could come up with. I'm only going to ask you for 4 solutions. And because I want everyone to come up with the same 4 solutions, I am going to ask you right now to use -1, 0, 1, and 2. Sometimes I may give you an equation that looks like this. 2x plus y equals 6. In this case, it's a little bit harder to do to find your solutions, but still possible. 0, no, not 0 first. What we say was going to go first. Yes. -1, 0, 1, and 2. And this time when I use -1, I'm going to go 2 times negative 1 plus y equals 6. Well, that's negative 2 plus y equals 6. I'm going to have to add 2 to both sides, so I'm literally solving the equation to get y equals 8. So my ordered pair will be negative 1, 8. Would you try the next 3 on your own? If you did this correctly, you would have found that 0 paired with 6, so I get 0, 6. 1 would pair with 4, so I would get 1, 4. And 2 would pair with 2, so I would get 2, 2. And those are 4 possible solutions. When you look at a graph, and a linear graph in particular, there are 2 very important ordered pairs or points that we want to make mention of. The first one is where the line crosses the x-axis. This is called the x-intercept. Now, unique about the x-intercept is that while it goes over somewhere on the x, the y will always be 0. Same thing over here, we have what's called the y-intercept. And yes, I'm abbreviating the word intercept, but y-intercept has a special property to it. What do you think that is? Yes. This case, the x is 0, and it will go up or down some b. Now, I have specifically used a and b, and the b will come up to be something important later. When you look at an equation, if I said to you, for example, negative 2x plus y equals 4, and I said find the x and y intercepts. Well, what's nice about the x and y intercepts, if I make an xy table, for the x-intercept, I can do what? Right, I can let y equal 0. And for the y-intercept, I can let x equal 0. So now if I go through and solve these, if I let y equal 0, I get negative 2x plus y. Nope, let's not put plus y. Let's put plus 0 equals 4. Well, that's just negative 2x equals 4, or x equals negative 2. So I get negative 2, 0. If I want the y-intercept, same thing. I do negative 2 times 0 plus y equals 4, which that's just 0, so I get y equals 4. So I get the point 0, 4. And what's nice about the x and y intercept is when they do come out to be whole numbers like negative 2, or integers like negative 2, 0 and 0, 4, I can simply plot those points and graph real easily. Take a look. If I asked you to graph the equation 2x plus 3y, let's not do plus. Let's do minus 3y equals 6. I want you to graph this equation, but I want you to do it using the x and y intercepts. Okay, let's see if you did this right. If you did it right, you would have told me the x-intercept would have been 3, 0. And the y-intercept would have been 0, negative 2. So if I graph, I would have gotten 3, 0. So there is 3, 0. And 0, negative 2 is right there. So my line would look like that. And there is the graph of 2x minus 3y equals 6. And do remember that every single point on this line is a solution. How many solutions are there? There's an infinite infinitely many amount of solutions. And that ends today's lesson. We will talk a little bit more tomorrow and continue on.